Welcome to Physics Hub. Today is Sunday and here we are with a new set video. So today we are going to discuss set 51 and this set contains questions from vectors and rotation matrix. So we have 5 questions. So before going to the detailed solutions, let me tell you that please follow our social media handles. We keep on sharing beautiful, interesting and important formulas, facts, and various kind of job notifications or PhD notifications, etc. So hope you will be benefited from those posts. So please follow our Facebook page, Instagram page, and especially follow our YouTube community post, because we create polls taking different MCQs from different topics of physics, and that really helps you. That will really help you to strengthen your base. Okay, so let's start today's set video. The first question reads like this. During a rotation, vectors along the axis of rotation remain unchanged. For the rotation matrix, the unit vector along the axis of rotation is. Okay. Now, during a rotation, the vector along the axis of rotation will remain unchanged. What does it mean? It means that the vector along the axis of rotation will be the eigenvector of the rotation matrix with an eigenvalue 1. Okay, so about the eigenvalue equation, R x equals to lambda x. So the vector which we are talking about, let's say that is x, and the value is a, b, c. So it's basically a column vector. So R is equal to lambda x. Now, as the vector remains unchanged along the axis of rotation, means the eigenvalue is 1. So 1 into x. Now the given rotation vectors is what is that? 0, 1, 0, 0, 0, minus 1, minus 1, 0, 0. So this is the rotation vector x. We have taken a, b, c, and that is x means a, b, c. Okay. Therefore, we can write 0, b, then minus c, this is minus a, and that is equals to a, b, c. Now we can easily compare the left hand side with the right hand side, and what we get, b equals to a, then minus c equals to b, and minus a equals to c. Okay. Now if we combine these three things, we can write a equals to b equals to minus c. Okay. Now this is the normal vector. So the elements of this vector are in some arbitrary forms. So we need to normalize this vector. So how to normalize it? So we will use the normalization condition. What is that? That the vector x should satisfy this condition, x dagger x equals to 1. Okay. Therefore, x dagger means it will be a, b, c, and x is a, b, c, that is equals to 1. Therefore, a square plus b square plus c square, that is equals to 1. Now you know that a equals to b equal to minus c. Now a square is there, means both the things are equal. So let's equate them to a single variable a. 3a square equals to 1. Therefore a equals to plus minus 1 by root 3. So this is the normalization constant we get. So what is the vector? So our desired vector is x equals to 1 by root 3 a, b, and a equals to b equals to minus c. So I cap plus j cap minus k cap. So this is the desired vector which we have to find out, and it is matching with option B. So option B is the correct option for this question. Let's quickly move towards the second question. The second question reads like this. Consider a cylinder of height h and a radius a closed at both ends, center at the origin. Let r be the position vector and n cap is a unit vector normal to the surface. The surface integral over r dot n ds over the closed surface of the cylinder is. So this is the cylinder. You are given XYZ coordinate system. The height is given to you, that is h, okay, and the radius which you are given, it is a. Now you have to find out the integral, surface integral for r dot n cap ds. Okay. Now how to find out this integral? To find out this integral, we have to use a divergence theorem. So using divergence theorem, using what we can write it in terms of volume integral, divergence of r dv. Okay, this we can write, and divergence, and r is given to you in the question, x I cap plus y j cap plus z k cap, and dv remains same as it is. dv is the small elemental volume of this cylinder. Okay, so if you do that, so divergence of this thing means del del x of x component, so derivative del del x of x is 1, so it will produce 1, and for y also del del y of y is 1, del del z of z is 1, and dv is dv. Okay, so this is basically 3 integration v dv. Now this integration over the volume is the volume of this cylinder. What is that volume? Area, that is area into height. So what is the area? Pi a square, this is the area, and height is h. So this is the volume, total volume of the cylinder, v equals to pi a square h, area times height. Okay, so that means it is producing 3 pi a square h. And let's check the options. So it is matching with option B. So option B is the correct option for this particular problem. Let's move to the third question of this set. The question reads like this: let A and B are two distinct three-dimensional vectors. Then the component of B that is perpendicular to A is. Okay, so you have to find out a vector. So you are basically given two vectors A and B, and you have to find out the component of B that is perpendicular to A. So what is the vector perpendicular to the, what is the component perpendicular to A? So the perpendicular component is this. This is perpendicular to vector A. Now you have to find out this component of B. Okay, now if the angle between the two vectors is theta, so what is the component of B along this direction? That is B sin theta. So you have to find out this component, and you can name it. The name of the direction is p cap. So we denote this direction as p cap. Okay. Now for this question, we have to apply this thing on all the options and check which option is matching. Okay. So let's start with the first option. The first option is given to be A cross B cross A divided by A square. Okay, so let's start with the basic one. So vector A we are keeping as it is, and B cross A we know from our high school level, BA and angle between them is theta, so BA sin theta. Now what will be the direction? So when you take a cross product, the direction is given in the perpendicular direction to both A and B. So if B is in this direction, A is in this direction, so according to us the direction of B cross A will be in this direction, perpendicular to the plane. So let's denote that by n cap. So what is n cap? N cap is the vector perpendicular, is the unit vector, perpendicular to both A and B. Okay, divided by A square. Okay, so BA sin theta we are taking outside, and A cross n. So the value of this vector, magnitude of this vector is A. The magnitude of this vector n cap is 1 unit vector, and A cross n means a unit vector will be produced perpendicular to both A and this n cap. So basically it will be in the p direction. So that is p cap divided by a square. Now one is cutting from here, one is cutting from here. So a square is getting cancelled. So we are basically getting b sin theta p cap. Okay, and so we are getting our desired component. So this is the correct option. So the correct option for this question is option A. So option is the correct option. Okay, let's move to the fourth question. So the fourth question reads like this. Okay, so before going to the fourth question, let me give you some formula. What are those formula? Rotation. So we will be discussing three cases. So case one. Case one is a rotation matrix. When the rotation is about z-axis, then the rotation matrix is given by this expression cos theta sin theta 0 minus sin theta cos theta 0 0 0 1. So when you will be given in the question that the rotation has happened about the z-axis, then this will be the rotation matrix. Case 2 is rotation about y-axis, and that is denoted by ry of theta. Well, this is the second case, rotation about y-axis. Let's move to the third case, case 3, when the rotation is about x-axis. So what will be the rotation matrix in that case? Rx of theta, that is equals to. So this three rotational matrix formula is very important to solve questions. The next question is based on these formulas. So let's solve that question. So question number 4. The question number 4 reads like this. Consider a vector p equals to I cap plus 2j cap plus k cap in the coordinate system j, I, j, k. The axes are rotated in the clockwise direction about the z-axis by an angle 45 degree. Okay, so I'm just showing the one coordinate, how it is being rotated. So unless if it is rotated by some angle 45 degree. So this is a rough scenario of the problem. Okay. The vector p in the rotated coordinate system will be. So in the first case, p is given to be I cap plus 2j cap plus k cap. Now rotation has happened in about the z-axis. So the rotation matrix which will come into play is Rz. That will operate on P, the vector P. Okay, and we have to, and that will produce basically P prime. That's the thing which we have to find out. Okay, so let's name it, because this we have to. Rotation matrix is a matrix, so we have to consider the vector as a matrix. Okay, so x prime, y prime, z prime is the vector. So we are basically talking about the component. That is a change vector, and that is producing because of the rotation matrix is applying on the vector. So what is the rotation matrix? Cos theta, then minus sin theta, 0. I'm rubbing it anyway. Then sin theta, cos theta, 0, 0, 0, 1, and it is being applied on some x, y, z. So this is the general formula which I am writing. So here theta is given to use 45 degree cos 45 minus sin 45 and 0. This is sin 45 degree cos 45 degree 0, 0, 0, 1. And x, y, z is 1, 2, 1. 1, 2, 1. Okay. So if you do that, so what will you get? Cos 45 is 1 by root 2, so 1 by root 2 minus 2 by root 2. So you'll basically get a column vector because 3 by 3 into 3 by 1. So it will be 3 by 1. Minus 1 by root 2. This is 3 by root 2. This is 1. And let's check the options which is matching with this. So it is matching with option 1. So option A. So option A is the correct option for this case. Okay. Let's move to the last question of this set. Question number 5. The question reads like this. So this question is a little bit big, but it's very easy. So let's read the question first. The question reads like this. Let sigma x, sigma y, sigma z be the Pauli matrices, and some big expression is given to you. Then the coordinates are related as follows. Okay. So let's write first. So what is the formula given to you? X. So basically what you need to do, we have to express this expression in terms of matrices. How can I do that? So first, if you don't know about these Pauli spin matrices, let me tell you what is the expression of this sigma x. Sigma x is given by 0, 1, 1, 0, sigma y 0 minus I plus I 0, and your sigma z is equals to 1, 0, 0, minus 1. So these are the Pauli spin matrices. Now, so basically, what does this part produce? Sigma x plus z 0, 0, minus z. So if you add them, what does you get? You get z x minus iy x plus iy minus z. Okay, so this thing you get for this part. Now the two remaining things are this and that. So if you find out one, we can easily predict the other. So first talk about this exponential I theta sigma z by 2. So exponential of a vector is basically exponential of a diagonal matrix is basically exponentiating each element of the matrix. Okay, so here the matrix is sigma z, so we'll basically exponentiate all the elements there, and that will produce e to the power I theta by 2. Sigma z is this, so e to the power I theta by 2, 0, 0, e to the power minus I theta by 2. So this is exponentialized theta sigma z by 2. Next, exponential minus I theta sigma z by 2. That will give you exponential minus I theta by 2, 0, 0, exponential plus I theta by 2. Okay. So we have found out the terms on the right hand side first. So let's take care of the left hand side part. Okay. Sorry, I rubbed it. So whatever we have found out for this case, it's just the prime. So we'll write in terms of prime. So this will produce basically z prime. So we are just adding a prime on whatever we get from this expression. On every element we are just adding prime because nothing is changed except the prime sign. Okay, so this is basically equals to, so what we get for this part, so we can write it like this: e to the power I theta by 2 0 0 e to the power minus I theta by 2. Okay, and this is z x minus iy x plus iy minus z, and this term is e to the power minus I theta by 2 0 0 e to the power plus I theta by 2. Okay, now we just need to compare on both sides. So I'm going to do that. So first we are keeping it as it is, and we are just adding these two things. So z plus e to the power minus it's a multiplication, not addition. So we have to add them accordingly. So how to add that? So z e to the power minus I theta. So video is getting longer, so I am just writing whatever I have calculated before. I theta by 2 x plus iy e to the power minus I theta by 2 minus z e to the power I theta by 2. Please check the calculation. This is simple matrix multiplication, so hope you will do it by yourself. So I'm just writing I have calculated. To save the time, I'm just writing the values for you. So this is the final expression we are getting. Now what we have to do, we have to compare the components on the left hand side and right hand side. So by comparing that, we get first thing z prime equals to z, this element and this element. Next, when we compare this and this, we get x prime minus iy prime, that is equals to x minus iy e to the power I theta. Okay, so x minus iy cos theta plus I sin theta. Now just separate the real part and imaginary part. So what we get, x cos theta plus y sin theta plus I into x sin theta minus y cos theta. Okay, so finally it will give you x prime equals to x cos theta plus y sin theta, and y prime equals to y cos theta minus x sin theta. Okay, so we have got x prime, y prime and z prime as well. So if you write them in terms of matrices, so what will you get? So now on the left hand side we are writing it as x prime, y prime, z prime. Okay, so on the right hand side we can write x, the component of x is cos theta, component of y is sin theta, so cos theta, sin theta, and no z component, so 0. In the next case, component of x is minus sin theta and y cos theta 0, and z prime is z, so I have no x and y component, so this times x, y, z. Okay, so and fortunately it is matching with option B. So option B is the correct option. Finally the end. So today we have discussed 5 good problems from vectors and rotation matrix. Hope you have understood everything. Irrespective of that, if you don't understand any part and if any confusion or problem arises, you can comment down below. I'll try my best to answer them or clarify them all. Those who are new here, please subscribe the channel and don't forget to press the bell icon. And finally, thanks for watching.